Hello, today we're going to do a nice bonus integral. It's really not too tough of an integral. It's quite simple actually. I know it looks pretty complicated and you can get lost in tricks here, but what we're basically going to realize is that the function we're going to find the antiderivative for is really not as complicated as it actually looks right now. So what we'll do is u is equal to the square root of x times the square root of x times the square root of x repeated. And we're going to use some tricks to simplify and get a better expression for u. So what's the main trick we're going to use? So this is equal to u, right? Obviously. But if we actually look at this nested square root here, we can see that that is also equal to u, right? Because it's just an infinite amount of square roots. So what we'll do is we'll write this as the square root of x times u. And now we can just solve for u. So this means that u is equal to the square root of x times u, or u squared is equal to x times u, or u is equal to x. But also equal still to this massive square root, which is the square root of x times the square root of x times the square root of x repeated. And we can substitute that in, but we don't actually really need to do anything. We can just say that this is equal to the integral of x dx, right? So just by realizing that our function is actually just equal to x, we can see that this is actually a really easy integral. I'll also use some visual stuff to prove this kinda. Of course, this is only true for positive values of x, but let's see. So this just means x squared over 2 plus c, and we're done. So actually, we didn't really need to substitute anything. We just looked at our function. Now another way to look at this, which is quite nice and a little bit more rigorous, is to consider the fact that we can use the square root of x just as basically powers of x. So that would be x to the power of a half times x to the power of a fourth, x to the power of an eighth, and so on and so forth. And then basically we just add the powers because it's a product, and we can see that that is actually a geometric series, right? So this would be x to the power of the sum from n equals 1 up to infinity of 1 over 2 to the power n, right? And that is an easy geometric series which just sums to 1. So we just get x. And by analyzing the function in this way, we can just still come to the same conclusion as before. And yeah, I think that's pretty clean, just realizing that this integrand is really not too tough, and we can just view it as a simpler function. This is a problem from the MIT integration B, but from the opening problems. So basically, if you wanted to participate, you could do one of these, or all of these, and I think it was pretty clever what you had to do here. So thank you so much for watching. Until next time,